Alright, the next topic is called logarithmic differentiation. Oh, that's a mouthful, huh? What the hell does this even mean? It's crazy. Okay, well, this is what this means. This is some craziness. I mean, you know what an exponential function is, and you should recall that logarithm is the inverse of the exponential function. Now, just so you don't get any cute ideas, when you take the derivative of x third, you can multiply by the power and subtract 1, right? When you have x to the p, that's the power rule. This does not work here or here, okay? This is not a number, this power. And this is even worse. I mean, this is 2 to the sine x. So the question is, how on earth do you take the derivatives of these? And you're going to use logarithmic differentiation. So way, way, way back in the day, pre-calc, you did properties of the logarithm function. You did a lot of stuff with exponentials and logs in pre-calc that you have long since forgotten. I mean, why the heck would you remember any of that? But there's a property that said when you had x to the p and you did ln of it, you were allowed to take this p and put it in the front. And the question is, why the hell is that going to help me? Well, very easy. I mean, let's say you wanted to do something more simple. I'm just going to make up another one. The problem is that this is not a power rule. This doesn't work that way. This is an exponential function. So what you have to do is you have to get this power out of there. It would be really great if I could somehow put the power in the front. If only I knew a way. If only I knew some property that could take the power from the top and move it to the front. So what you're going to do, if it's not obvious, is you're going to take the natural log of both sides. Then you're going to use the property of logarithms to move this to the front. Then you're going to take the derivative. Like, wait a minute, what the hell? You're going to take the derivative of this side and the derivative of that side. All right, this is the gist. I mean, I'm doing just nonsense here. This isn't a real example. I just want to show you what you're going to do. So I'm going to write the steps down, and then I'm going to do a couple of examples of it. It's not that bad. It gets nasty. I mean, I'm not going to lie to you. These problems can be pretty monstrous. When this is an x, you're going to have ln x here. And you notice I emphasize this little dot here. So you're going to use the product rule during these problems. And when you take the derivative of this side, if you remember how to do ln u, it was du over u. So this this side's not going to be that nice either. These derivatives can get kind of messy. So I'm going to write the steps for you. Alrighty, the steps. You're going to take the natural log of both sides. Why you're doing that? The reason you do that is to take the power of the exponential function and move it into the front. Once you've done that step, then you can take the derivative. Taking the natural log of both sides is not the derivative. So look, again, I'm just making up a different problem here. Let's say I had something like that. My first step would be to take the natural log of both sides. Now, why did I do that? I did that so that I could use the property of logarithms to pull that power into the front. Now it says take the derivative of both sides. Okay. Remember, when you take the derivative of y with respect to x, chain rule, right? So you're going to get du over u. So the du here is y prime. Right? This is how you take the derivative of ln u. It's du, which in this case is y prime, right? The derivative of y over y. That's how you do the derivative of natural log. And then this side, you'd have to use the product rule. This is a constant, though. So it's kind of trivial, right? When you do first, derivative second. The derivative of ln 3 is 0 because ln 3 is a number. This is a constant. This is fixed. So this one is pretty easy. But I wanted just to see the idea of this. Once you take this derivative, right, you're going to have this derivative sitting here. I want to know what y prime is. So you're going to take this y and you're going to move it over to that side. That's why it says multiply by y to get y prime. You want to get y prime alone. So this y is going to end up over there. That's why these answers get pretty nasty. All right, I didn't want to work this one all the way. I just want to show you the idea of the steps. Natural log both sides. Move the power in the front. Take the derivative of both sides, which I didn't finish. And then at the end, you're going to move the y over. And you'll have y prime alone on the left, okay? You'll see when I do the two examples. And again, it's going to get nasty. I think maybe I'll finish this example. All right, so I decided to go back to the example I had in the very beginning, which was y equals 2 to the sine x. Like, what? So, step 1, natural log both sides. Step 2, power goes in the front. Make sure you put your dot. Product. Take the derivative of both sides. What's the derivative of natural log y? Y prime over y. This is the derivative of ln u. du over u. Now, the derivative of this side. It's first, derivative of second, plus second, derivative of first. What's the derivative of sine x? Cosine x. So this is going to be gone. Right? That's 0. So I get that y prime over y equals ln 2 times cos x. Now I got to take this y, multiply both sides by y. What the hell is y? What the hell is y supposed to be? Where did y come from? I don't know where y is. I don't know what to do. So, once you get over your insanity, this is crappy y. My prime looked okay. You have all this stuff, plus the dude you started with. What did you start with? 2 sine x. Look at that derivative. Oh my gosh. Crazy. Did I really just say gosh? This is nuts. This is what it is. This is a nice one. Right? I haven't even done a nasty one. You're going to do the nasty ones. I did an easier one for you, but this is the gist. ln both sides. Move the power up in the front. Take the derivative with the product rule. Here it's trivial because this is ln 2. Constant. Derivative of a constant is 0. The next one I do, it's not going to be 0. So this answer is going to be even more nasty. So, and then the y has to move over because you need y prime alone, right? You're taking the derivative. I want the derivative of this thing. So since I took ln, my derivative became more complicated. I can't just do y prime here because this derivative is not trivial. You can multiply by sine and subtract 1. No, you can't. All right? That's nonsense. I'm going to do one more example, and then that's all she wrote. All right, so here's a special one. Y equals x to the x third. I've seen them do some crazy crap where they do like x to the x to the x. Screw that. This is good enough. All right? Exponential function. The base is x. The power is x cubed. Craziness. But it doesn't matter what it is. Take the natural log, both sides. This is always going to be the step. It's very straightforward to do. Even if it gets nasty, this is not difficult. Compared to the crap you've already done, this is a whole lot of nothing. Move the power in the front. Now again, product. Take the derivative now. The derivative of ln y is y prime over y. Right? When you have ln u, it's du over u. Now the other side. First, derivative of second. I don't remember what the derivative of ln x was. Plus, oh man. First derivative second. What's the derivative of ln x? 1 over x. first, derivative second, plus second, derivative first. If you don't know what the derivative of x third is, go home. Well, you're already home if you're watching this. Now, let me neaten this up a little bit. Don't leave this like this. This is ridiculous. You have x3 on top, you have x on the bottom. That gives you x2. Plus, I want this in the front. Now, don't get any cute ideas. Make this 4x squared. Why can't you do that? You have x squared, you have 3x squared. You can combine them. This is not a loan. Yeah, these are like terms. If I just completely forgot about the ln x, I could add them together, but you cannot. All right, but you can factor it out. No, don't do that either. All right, I'm about to move this to the other side. I'm going to multiply both sides by y. Knock that out. Now prepare yourself for the horror of this answer. These parentheses better be here. Be very careful. I do not want you to factor out. This crap is nasty enough. What was y? You always get the original dude in his derivative. Remember, when you took the derivative of e to the x, it's e to the x. When you take the derivative of ex squared, it's 2x times ex squared. You always get e in his derivative. This is an exponential function, and so is e. He will always be in his derivative. He's always there. He just gets a bunch of other weird-ass crap with him. Okay, so these derivatives are very nasty. I mean, look at this answer. I mean, this is involved. You are not going to guess this. All right, there's no trivial way to do this. Think, I can do this in my head. I know how. No, you can't. All right, you have to write all this out the way that I did. And you always end up using the product rule, especially when this is an x. When this is a number like 2 or 3, this becomes trivial. Because if this was ln 2, like in the previous example I did, the derivative of that was 0. So this whole term disappeared. So you actually got a nicer answer. When there's an x here for the base, this gets much nastier, okay? So same thing, ln, both sides, power to the front, take the derivative. It's always y prime over y here. Always, always, always. This side I had to use the product rule. First derivative second plus second derivative first, blah, 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 blah. I neatened it up. I moved the y over, and then I rewrote my final answer to look all pretty and nasty. All right, so this whole process, logarithmic differentiation. Good luck with that.